Okay, so the topic today is programming constructs, and the subject that we're looking at is computer science. Please take extra care over this topic. It's a really, really important topic for your GCSE, and there's some fundamentally crucial concepts that you need to grasp. So we're going to go over to Mr. Holton to explain what they are.
Every computer program is made up of one or more of these following programming constructs. And so knowing what programming constructs are and being able to identify them, and really importantly knowing which ones you need to use to solve a problem, is so important when you go and do any sort of programming or you look at any sort of program as well. So we're going to cover the main three types of programming construct here. And we're going to start out with the basic one, so that every single computer program will have sequencing in it. And this is just the idea that after you've written a computer program, the computer takes that program, runs it from top to bottom in order. And I'm going to give you an example program of all these programming constructs as we're going along. And this one's fairly straightforward with sequencing. So let's have a look at 2 lines of code here. And sequencing really is just a simple idea that the first line of computer program that gets run is this top one here where it says print hello. So you'll see hello on screen. And the second line that gets run is the one below it. So my_num equals 6. It sets a value into a variable. That's the idea of sequencing, that we go from top to bottom normally, unless something affects the order, which are the other 2 programming constructs actually, which we're going to talk about now. So another one is selection. That is your second programming construct. And this is the idea that we can change what code is run based on a condition. And you'll get to see what I mean by condition in a moment, because conditions are really important for both selection and iteration. So let's write a little bit of computer code for this. Almost all programming languages use if statements when they're dealing with selection. So let's write an example one here. So if my_num is greater than 5, print high, else print low. And what happens with an if statement or selection is this: the condition is evaluated. And that means we look to see if this here, if my_num greater than 5, if that is either true or false. So we got my_num set to 6 here. So if my_num greater than 5, well, because my_num is 6, that is therefore true. And if that is true, if the condition is true, then the top part of the if statement is run here, so we'll get the print out high and we won't get low printed out. But if I change my computer code a little bit higher up here, so let's change this so no longer it says my_num equals 6, let's do, I don't know, my_num equals 3, then that would switch around, because if my_num greater than 5 now equals false. So because of that, the false part of the if statement is run, so that's anything after the else, and so I'll get the word low printed. So it's just the idea that we have a condition, and if that condition is true, one part of the code is run. If it's false, another part of the code is run. Okay, so there's sequencing and selection. And now we're going on to iteration. And this is the bit which can blow people's minds. But this is just a simple idea that we repeat code, and we can repeat code based on either a condition, just like with an if statement, or a set number of times. And that's called either condition controlled or count controlled. So I'm going to give you an example of condition controlled iteration now. We'll start off with that one. So let's have just a bit of sequencing. So my_num equals 0, and then after that I'm going to have a while loop, and the while loop is the bit which is iteration. Okay, so that's your iteration programming construct, or one of them anyway. So while, and then we're going to have a condition, my_num, let's do my_num is less than 2. Okay, so whilst my_num is less than 2, then we're going to run the computer code, and we're going to keep doing it until my_num is no longer less than 2. And so we'll have what? We'll just do something simple here. My_num equals my_num plus 1. Okay, so we're just going to add on 1 to my_num each time. And what we need to do is follow along what happens in this computer program and what order things happen in, because the loop makes the code repeat. This is the bit which people sometimes find confusing. So what I'm going to do is draw an arrow here on that side here, and we're going to have a look to see sort of how the program moves and changes. I'll add an extra line of code onto the bottom here, just a print statement, so we can see when that is actually eventually run. And then we're going to keep track of what's in my_num. If you remember the idea, we have variables in boxes, so this would be an integer box, and that's going to start off with the number 0. Okay, so let's get going. First line of code that's run is my_num equals 0. So far, so good. Next line that gets run is this. Whilst my_num is less than 2. Well, is my_num less than 2? Yes, it is, because it's 0. So we move on to the next line of code, which is here. My_num equals my_num plus 1. That means we're adding 1 onto my_num. So let's get rid of that 0 and put a 1 in there. And this is the bit which is really important. This is the bit which makes it iteration. We do not go on to a next line of code, which might be on down here. We go back to our while loop. Okay, we go back to our while loop here, and then we check again. We say while my_num is less than 2. So is my_num less than 2 yet? No, because is my_num less than 2 yet? Yes, it is. It's 1. So we go back to this line of code here. My_num equals my_num plus 1. Let's change that. So my_num now equals 2, and then we go back up again, and we're going to check here again. So whilst my_num is less than 2. It's no longer less than 2 because it equals 2. So what happens now is we exit that loop, and the next line of code, which could be run, which is down here, gets run, which is that bit where it says print finished. So that's an example of condition controlled iteration. There's another type of iteration. I won't go through the full example for it, but that's called count controlled iteration. So let me give you a quick example, and it will look something like this. Count controlled iteration. It will be for, because for is the word that we use for count controlled iteration. For I equals 0 to 5, and then we'll have a bit of sequencing after that. So print. This will be printed out 5 times. And if you ran that code, what would happen is anything within the for loop, so this line here, in this case, would get run 5 times. So sequencing, the idea that we're running from top to bottom of the code. Selection, those if statements, so we choose what kind of code is going to be run based on the condition. And iteration, the idea that we're repeating or looping code based on either a condition, so condition controlled iteration, or a set number of times. That's count controlled iteration. They're your programming constructs.
So now we've heard about sequence selection and iteration from Mr. Holton. It's time for your first task. So in your first task, the idea is that you are doing a kind of matching exercise and looking at some pseudocode to identify some of the constructs used. So 10 minutes, off you go. And that is time up on the first task. So we're going to ask Mr. Barnes now to review that task, and he'll explain the answers.
Okay, so hopefully you've learned a little bit about the 3 key programming constructs and how to go at this activity. So what we're going to do now is just going to go through it. So we've got 3 programming constructs: sequence, selection and iteration, and we've got 3 possible answers here. So let's have a look. So this is when a program will change its path based on a condition. Well, that answer is selection, because an if statement, it says if this, do this, otherwise do something else. So it changes what it does depending on what that condition is. Okay, so if traffic lights equal red, we stop. If they're not, we go. Next we've got this is when program repeats code. This can happen for a set number of times or while until a condition is met. So repetition is known as iteration in programming. You iterate, you repeat, and then that means that sequencing is when any set of instructions are carried out in order, first to last. Okay. So the next part of the task is you've got 3 different algorithms. You need to identify what programming constructs are used and what lines you can see that on. So let's start with this first algorithm. So as soon as you see an if statement in a program like we've got here, your first answer should always be selection. So we've got selection. And what lines have we got that on? Well, we've got it on lines 2 and lines 4. Now, the other thing to be wary of is almost every program will have sequencing, because sequencing is just doing something in order. So you could say here from going from line 1 to line 2 is sequencing. So I'm also going to write sequencing. However, I think the key thing to note here is if it was an exam question, you got asked to identify one programming construct, then I would always pick selection in this case, because that's clearly what the exam board are looking for. Now, if it got asked for name 2 different programming constructs, then you would also pick out sequencing. Okay, so just bear that in mind. So next one then, we've got an algorithm here. We've got number of words, number of chapters, blah 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 blah. We've got 1, 2, 3, 4, 5, 6 lines of code. First of all, I can't see an if statement, so I know there's no selection there, so I can immediately rule that out. With iteration, there's a specific way you can spot this as well. So iteration, you're looking for a for loop, an until loop, or a while loop, and that's not apparent in there either. So we can rule out iteration. So that means we've got sequencing, because it's doing each line in order, one after another. Okay, and where have we got that? Well, it's throughout, isn't it? Okay. And then finally then, we've got this algorithm. What programming constructs are used and what lines can you see them? Well, I'm going to highlight some keywords here. The word for and the word if. So straight away, as I just said on the first example, that if we've got an if statement, we've got selection. Okay, and that is on line 1, 2, 3, line 4. Okay, we've also got a for loop. So when we've got a for loop, that means we've got iteration, because it's going to repeat something. And that's on line 2. And you could argue that it's also got sequencing. It goes from line 1 to then line 2. It goes from line 3 to then line 4. So it's doing things in sequence. Okay, but as I said before, chances are in an exam question you might get asked for, given an algorithm like this, get asked for 2 programming constructs, in which case they're looking for iteration and selection being identified. Okay, so key things here is iteration. To identify iteration, you're looking for, while, or until. Okay, for a selection, you're looking for an if statement, and sequencing is just when it does stuff in order.
So now, as ever, your final activity is some exam questions. Again, these will be reviewed by Mr. Barnes after you've completed them. You've got 10 minutes to complete the exam questions. Give them your very best shot, and then you'll mark them afterwards. Okay, that's time up, so we're going to go over to Mr. Barnes. He's going to review your answers. Please make sure you correct any answers that you didn't get quite right. Over to Mr. Barnes.
Okay, so now you've completed the short activity on programming constructs. Let's have a look at how this applies in exam questions. Okay, so here we've got a taxi uses a computer to communicate with the central office and to calculate customer fares. The program in the computer uses sequence selection and iteration. State whether the options below use sequence selection or iteration. So we need to pick one of those from each. So the first one is we've got performing a series of different setup operations when the computer is switched on. So if it's performing setup operations, it's doing it in order, therefore it's going to be sequence that it uses. It's doing something in sequence. Beeping repeatedly after a message is sent until the driver presses a button to show the message has been read. So as soon as we see that word repeat, we know we've got iteration. Okay, and deciding whether to use the daytime rate or the evening rate to calculate a customer's fare. So here we're deciding which direction to go down based on a condition. Is it daytime or evening? So that means we need an if statement, which means we're going to have selection. Okay, so let's just shuffle that up slightly. Okay, so having a look at the answers here, nice and easy. Sequence, iteration, selection, 3 marks. Okay, right, let's go on to the next question then. So we've got here, Julie is writing a computer game that simulates a 100-meter race. Each time the spacebar is pressed, the position of the player moves up by 1. When the position reaches 100, the player has won. Here is Julie's algorithm. Okay, so we've got an algorithm that's about 8 lines of code here, and it says, state what is meant by selection and iteration using examples from Julie's algorithm. Okay, so what it wants is it wants a definition of what selection is and then where you can see it. Okay, so the key thing here is with selection, I keep talking about how you know when there's selection because it's got an if statement. But if you just wrote, oh, it's an if statement, it's not going to get you the mark. So what actually does it mean with when there's an if statement? Well, that means selection is when there is a condition that is checked to determine which path the program follows. Okay, because if the if statement is true, it does one thing. If it's false, it does another. So where in this algorithm can we see selection? So we can see selection here. We've got an if statement. So the key thing here is what is happening based on that selection. Well, the position will increase by 1 if the spacebar is pressed. Okay, because it says here if key pressed equals player key. Well, we said here player key is a space at the top. So if the key that they've pressed is a space, then it's going to increase the position by 1. Okay. So then we've got iteration. So iteration, I said you're always looking for a for, an until, or a while loop. So here we've got an until loop. Alright. Now, how do we define iteration? Well, iteration is probably easier than selection to explain. This is when code is repeated. Repeatedly executed. Now, the reason we can't say just it's when repeated, because it could be that the same line of code is written again. So it could be like print hello world, print hello world, print hello world. That is when code's repeated, but it's not being repeatedly executed. Okay, the same line being repeatedly executed. So what is our example here? Well, we're going to say there is a loop that repeats until the position equals 100. Okay, so let's have a little look at the mark scheme for this one. Move up very slightly. Okay, so we've got here selection. A condition is used to decide whether code should be executed. A condition is used to determine which path the program follows. Absolutely. The position will increase by 1 if the space bar is pressed. Position equals position plus 1 is only run if the condition's met. So the condition is the space bar pressed. Okay. Iteration. Code is executed repeatedly. This is when code is repeatedly executed. Perfect. The code in the repeat loop will run 7 times. A loop that repeats until the position equals 100. Perfect. 4 marks. Okay. So let's move on to the last couple of questions then. So we've got here an algorithm is written that finds the mean average, i.e. the total of the numbers divided by how many numbers there are, of a set of 10 numbers stored in an array called number array. Okay, so we've got an algorithm, and then it says the algorithm uses iteration. Describe what is meant by iteration. So this is fairly straightforward. So we've got 2 marks though. That's really important. So just saying that this is when code is run repeatedly or there is a loop is only going to get us 1 mark. So let's start off with that. So this is when a loop is used to repeatedly run code. Okay, so that's got me a mark, which is great. Okay, so how else am I going to get the other mark? So I'm going to then say what the different types are. So a loop can run for a set number of times, or while until a condition is met. Okay. Then I've got identify 2 forms of iteration that are not used in this algorithm. Okay, so let's have a look at the algorithm. Let me pull it back down a little bit. So in this algorithm, we've got iteration. We know that because we've got a for loop. Okay, so a for loop is a count-controlled loop. It will repeat for a set number of times. Okay, however, the other types of loop are what we call condition-controlled loops, and there's 2 of these. Now, one you've probably used in Python, which is a while loop. Okay, the other one is what we call an until loop. Alright, now if you've programmed in Python, you will have never come across an until loop because they don't exist, but you've got 2 types of loop. They're both condition-controlled loop because it will be while a condition is met or until a condition is met. Okay, right, let's shuffle this up a little bit and get the answers. Okay, so we've got here for describe what is meant by iteration. It is a construct, we could say that, but I haven't. Code is executed or run repeatedly or is looped. Well, we've got that is when a loop is used to repeatedly run code. So I'll take that mark. And then it says until a condition is met, while a condition is met a set number of times. Well, I've said that. I said a loop can run for a set number of times or while until a condition is met. Perfect. So 2 marks. Okay, the other 2 forms are while or do while or until or repeat until, do until are all accepted. So there we go. 4 marks.
And that's everything you need to know about sequence, selection and iteration. It's a really crucial topic, so I hope you took a lot from it. We'll see you next time.